What if I told you that a project can pay back on paper and still not actually earn your required return? When most people hear the word payback, they think it's simple. You invest money today, and over time the project generates cash inflows. Once those inflows add up to equal your original investment, you say the project has paid back. If you invest $400,000 and collect $400,000 over the next few years, that's payback. Simple. But here's the problem. Traditional payback treats a dollar received 5 years from now the same as a dollar received today. It completely ignores the time value of money. It assumes money doesn't earn interest, doesn't have opportunity cost, and doesn't lose purchasing power over time. In engineering economy, that assumption can be dangerous. That's why we use the discounted payback period, or DPBP. Instead of just adding up cash flows, we discount every future dollar back to present worth using the minimum attractive rate of return, or NPER. Then we track how long it takes for the cumulative present worth to turn positive. That moment is the discounted payback period. Before we go further, it's important to distinguish DPBP from present worth. Both methods discount cash flows at the NPER, so both account for the time value of money. The difference is in what they measure. Present worth asks, how much total value does this project create in today's dollars over its entire life? Discounted payback period asks, how long does it take for this project to break even in today's dollars? Present worth measures overall profitability. DPBP measures recovery time. Let's walk through an example. Imagine a company invests $400,000 in new production equipment. The machine generates $150,000 at the end of year 1. In year 2, it generates $125,000. In year 3, $100,000. The cash flows decrease by $25,000 each year until year 6, and by year 7, there's no remaining cash flow. The company's NPER is 10%, and the planning horizon is 7 years. What is the project's DPBP? At first glance, you might be tempted to just add the cash flows. If you did that, the investment would appear to recover relatively quickly. But that ignores the required 10% return. Instead, we discount each cash flow back to present value using the 10% rate. The $150,000 in year 1 becomes about $136,364 in present worth. The $125,000 in year 2 becomes about $103,306. Year 3's $100,000 becomes about $75,131. We continue this process for every year. Then we accumulate those discounted values. At time 0, we start at negative $400,000. After year 1, we're still negative $263,636. It remains negative year after year until finally, in year 6, the discounted cash flow pushes the cumulative present worth into positive territory. That tells us something important. The discounted payback happens between years 5 and 6. To find the exact timing, we interpolate. We take the remaining unrecovered amount at the end of year 5 and divide it by the discounted cash flow in year 6. When we do that calculation, the discounted payback period comes out to approximately 5.21 years. If we assume end-of-year cash flow convention only, we would report it as 6 years. But with interpolation, we can estimate it more precisely. Notice something critical. The regular payback period would have occurred sooner. Discounting delays recovery because future cash flows are worth less today. That's why discounted payback is always equal to or longer than the traditional payback period. Now let's look at another scenario using Excel. Suppose a manufacturing company invests $500,000 in a new machine that generates $92,500 per year. The NPER is 10%. Instead of manually discounting each year, we can use Excel's NPER function since the problem involves consistent annual payments. By entering NPER with a 10% rate, a $92,500 annual return, and a $500,000 investment, Excel calculates that the discounted payback period is about 8.16 years. Finally, let's zoom out to multiple alternatives. Imagine comparing 3 different projects. When ranked by discounted payback period, the order might be C, then B, then A, meaning C recovers fastest. But when ranked by present worth, the order might be completely reversed, with A creating the most wealth. That's not a contradiction. Remember, discounted payback measures recovery speed. It is essentially a risk metric. It tells you how long your capital is exposed. Present worth, on the other hand, measures total value creation. A project that recovers quickly may not generate the most wealth. A project that generates the most wealth may take longer to recover. Let's look at an example. An engineering company is considering 3 alternative designs, each differing in complexity, cost, and predicted revenue. The first alternative, Design A, requires an investment of $300,000 and produces an estimated revenue of $55,000 annually over a 10-year planning horizon. The second alternative, Design B, requires an investment of $450,000 and is expected to generate annual revenue of $80,000. The third alternative, Design C, requires an initial investment of $150,000 and produces annual revenue represented by a decreasing gradient series, starting at $45,000 in the first year and decreasing by $5,000 per year to a final value of 0 in the last year. A negligible salvage value is assumed for all designs. Assuming a MARR of 10%, which alternative has the smallest DPBP? Because designs A and B both have uniform annual values, we can use the Excel NPER function to find their DPBP. To deal with Design C's non-uniform cash flow, we use the Excel solver function. Solver is set up to find the DPBP that makes the present worth equal to 0. Based on the discounted payback period, the rank-ordered preference for the alternatives is exactly the reverse order of their present worth values. This is critical to understand, as DPBP can lead to incorrect conclusions about which alternative maximizes economic worth. So when should you use discounted payback period? It's especially useful when liquidity matters, when capital is limited, or when management is highly risk-averse. It provides a clear measure of how long funds are tied up. But it should never be used alone, because it ignores cash flows that occur after recovery. The key takeaway is this: discounted payback period improves on traditional payback by accounting for the time value of money. It tells you when your investment truly breaks even at your required rate of return. It can be fractional. It can change project rankings. And it highlights the trade-off between speed of recovery and total profitability. So here's the question for you. If you were choosing between 2 projects, would you rather recover your money faster or make more money overall? That decision is exactly why understanding discounted payback period matters. If you found this video helpful, consider liking and subscribing. Thanks for watching. I'll see you in the next video.